Morning, ladies and gentlemen. I'm one of the founders of the Dearman engine company. I'm not an engineer, so I feel a bit of a fraud in this building. The engineers send me out to these events because they find it amusing for the Q&A. So bear with me. We are developing a novel patented zero-emission engine that runs on liquid air. Now, until a year ago, I didn't even know air could be a liquid. Apparently, though, if you take 700 litres of air, or thereabouts, and you pass it through a standard industrial refrigeration process used by Linde and BOC and the likes of those guys, been happening for 100 years. You reduce the heat, you compress it, take it down to minus 200 degrees or thereabouts, you get 1 litre of liquid air, which you can store at atmospheric pressure. If you warm it up again by adding ambient heat, then you can regenerate it to be 700 litres of air. If you do that in a confined space, you get pressure, you can do work. Peter Dearman is a classic British inventor. He would be very at home in this building. He works out of his garage. He came up with this idea. It's now being taken very seriously. There's a conference being held on the 9th of May to announce a report by the Centre for Low Carbon Futures. John Hayes, the Energy Minister, has said that he thinks liquid air has the potential to be a global market worth tens of billions of pounds. Now, this is a little demonstration of what happens when you put 1 milliliter of liquid air into a bucket of water containing about 30 litres. This whole slide, which goes on for about a minute, it's a good way of filling 5 minutes, actually takes about 20 milliseconds to happen. And what you can see is a huge generation of activity. And that's really because the liquid air, in this case liquid nitrogen, which is 78% of the air, is taking the heat out of the water and is expanding rapidly. And in fact, if you look, you can't really see it on that, but if you look at the top corner there, you can see the water coming out of the bucket. That's about a foot above the bucket. So that's pretty impressive. I'm not sure if this is going to... Oh, it does. So what we're working on is a high-efficiency, low-grade waste heat recovery system. The beauty of starting at minus 200 degrees, as compared with the standard organic Rankine cycle, getting out over my physics skis, is that we can, starting at a much lower temperature, means you have a much greater Carnot efficiency, about 4 times of a standard process. That means that if you take, actually I'll go back to that slide, if you take a 300 kilowatt truck engine, that might project as much as 2/3 of that in heat, and a large proportion of that through the radiator. Now we believe we can turn up to 50% of that back into motive power. And what that means is, for our primary market, which is HGVs, buses, urban delivery vehicles, which have tremendous regulation and emissions issues, a relatively small Dearman engine, as a supplementary donkey engine, if you like, could deliver up to 30 kilowatts of additional output by taking heat off the radiator. There's almost no impact on the other IC engine systems. And it's additive to other energy-saving technologies. It's, in fact, will be additive to a fuel cell, because hydrogen fuel cells have the same issues over rejected heat. We're looking at working with bus companies, for example, because one of the issues of buses, they'd like to go to start-stop technology. They can't, because you have to let the passengers off at some point, which means you have to allow the doors to work, and you have to have heating within the bus and lighting when the engine's off. At the moment, you can't do that we can do it with batteries, but they're very heavy and very expensive. One of the things about this engine is it's likely to be very cheap. It uses an entirely mature set of components. It is a piston engine after all, and we've been inventing those for well over 100 years. So it's a fraction of the cost of a hybrid battery, a hybrid technology. Where we are in development, by the end of this year, working with our partners, Ricardo, we will have a test engine in the cell. By the middle of next year, we'll have a proof of concept vehicle. And in fact, going back to Autodesk earlier, this little model here was done by one of our guys using Autodesk. So thank you for your assistance, sir. It is very good. We've got a lot of academic partners, University of Brighton, Loughborough, STFC, Rutherford Appleton Laboratory, Leeds, Queen Mary, and others coming on board. And if you want to learn more, we're not actually fundraising at the moment, but there is this report coming out on the 9th of May, and I think that'll make quite a big splash. The last time we issued a report, we were on CNN, Sky, ABC News in America, Bloomberg TV, yada, yada. So I think the world is ready for a liquid air car. Thank you.